Hi, welcome to Tambu Higher Secondary School tutorial series, and today we are going to look at artificial intelligence, when and where it is used with some examples. AI is mostly used to predict future events, for example, based on a range of current and past climatic conditions including wind direction, cloud movement and so on. The AI can predict the weather for the next day, next week or so on. Similarly, AI is used for face recognition as you would have them in phone to unlock the same. YouTube recommendations based on your search history, self-driving cars and predicting share market in healthcare to predict the future medical condition like heart attack and so on. In this tutorial, we will see how it is done with simple examples. Assume that you have a stomach pain and you go to a doctor and tell him your issue. The doctor will give the most probable cause of the trouble, and what the doctor says would be right most of the time, because he would have seen hundreds of patients with the same symptoms and cause. The doctor will not be correct all the time, but the probability that an experienced doctor is correct is more. A machine learning model is exactly same as that of a doctor. You teach the model how to predict with historical data points. Once the model has learned, it can predict for the new data point. We will see that with an example.
Assume that you have RPM and temperature data of thousands of car engines, few of which is represented in the table. When the RPM is 3000, for example, its temperature is 100 degrees Celsius. When engine RPM is 2000, its temperature is 80 degrees and so on. Assume that the plot on the left represents the table on the right, where x-axis is RPM and y-axis is temperature. From the plot, the relation between temperature and RPM looks fairly linear, that is, a straight line. Now, a new customer comes and says that his engine will run at 10,000 RPM and wants to know what would the approximate operating temperature be. So, with the help of historical data you already have, you need to predict the temperature of new engines which runs at 10,000 RPM. We will see how we can do this by using a simple machine learning algorithm called linear regression. In linear regression, we draw a linear straight line along the data points such that it is closest to most of the points as shown in the figure. To predict the temperature for 10,000 RPM, we find the y-axis value of the regression line corresponding to 10,000 RPM. Say it is 200 degrees. So we make use of historical data points to find the equation of the prediction line. Prediction line in this case is called model, and the process of computer building this prediction line using historical data is called training the model. And then we make use of the model to do the prediction. The historical data used to train the model is called training data, and the data on which you perform the prediction is called test data. The result of the prediction, temperature in this case, can be any value like 200, 200.1, 200.01, 202 and so on. So, predicting something like temperature which can take infinitely many values is called regression.
Now, consider the second plot, which is almost same as that of the first one. You have an added information, that is, if the engine will break down or not after 1 year of usage. You can observe that the engine fails or breaks down for higher values of temperature and RPM, which is represented by green data points, and the blue data point represents the safe operating conditions of the engine. Now, you have a new engine represented by a red point, for which you know the RPM and temperature, and you have to predict if this new engine will break down or not based on the training data. For the same, we have a machine learning algorithm called support vector machine, which splits the entire space into two parts. Using this line in this case such that all the data points which belongs to a particular class falls on the same side of the line. Now since the new data point falls on the side of the green color point, we classify this new point as a green data point. The second one is an example of classification because you are trying to classify the new data point into one of the many categories. There can be 2 or 3 or more categories in classification. Whereas in regression, you are trying to predict something like temperature, which can take infinitely many values like 100, 100.1, 100.01, 100.001, 102, and so on. Both the above two cases is an example of supervised learning because you teach the algorithm to predict using historical data. You also have unsupervised learning where you don't teach the model how to predict, and also have something called reinforcement learning. We'll see an example of unsupervised learning next.
Now you have a picture of a woman shown on the left and assume that the picture is made of 5 shades of blue shown on the right. Given that the picture is 5 megabytes in size. Now your objective is to reduce the size of the image. One option is to reduce the total number of colors used in this image. So instead of using all the 5 colors, we can use say just 2 colors. For that, we can split the entire color spectrum into 2 groups and choose one representative color from each group. So now we can replace all the colors in the first group with its representative color and all the colors in the second group with its representative color. So finally we have replaced 5 colors with 2 colors, thereby reducing the size of the image. In machine learning, we have something called clustering to group based on similarity between them as we did for colors in this image. This picture was taken from a machine learning book. Here, clustering algorithms was used to group similar colors to reduce the size of the image. K represents the number of groups or clusters to be created using clustering algorithm. It can be observed that the size of the image reduces as K reduces. So, if K is equal to 2, then only 2 colors are used in the entire image.
Let's look at another example. Assume that I have RPM and temperature of about 30 different engines as shown, all of which are defective. My job is to fix these defective engines. I have 3 engineers working for me fix the defective engines. So I want to split the 20 defective engines into 3 groups such that each engineer works on one group of engines. I want to split the group such that the engines in each group is more similar to other engines in the same group than engines from the another group. This is because it will be easier for engineers to work on engines with similar performance. We can create 3 groups as shown using clustering algorithm. Here we group the data based on distance between the points. K-means is an example of such distance-based clustering. Clustering is an example of unsupervised learning because we don't teach it how to predict the group or cluster using historical data. Rather, it simply predicts on the fly. In K-means clustering, one of the main parameters we need to choose is the total number of clusters that we need. There are clustering algorithms where the number of clusters are chosen by the algorithm itself. But we won't go there now.
Previously, we saw how we can perform classification by splitting the 2 categories of data using a straight line. But if the data is not linearly separable like a new plot on the right, then the classification models cannot be a straight line. Instead, a curved line as shown. The second model is a bit more complicated than the first one as it will have more parameters. The prediction model need not be linear like the first one or curved like the second one, but it can be of any shape or logic imaginable. It takes just one line of code to build a model of any complexity. But how does the analyst decide how complex should be the model be? Let's see that with an example. So with this training data, we are supposed to create a SVM classification model to classify the two groups of data. We know that SVM splits the entire space into two parts, separating the two classes of data. However, we can observe that there is a green data points among the blue ones, making it impossible to clearly separate the two groups of data. Most of the real-time data looks as such and will not be clearly separable. So we can draw a straight line like this to separate the two classes of data. So if we have a new data point, it will be classified as blue class because it falls on the side of blue data point. Even though the classification model has misclassified this particular training data point, it still looks like the model has separated the two class of data with. But if we choose to increase the complexity of the model to correctly classify this outlier green data point as well, then we might get a model as shown. Now, even though this model classifies all the training points correctly, it might not be good classifier. Because for example, this new data point will be classified as green data point, even though probability of it being a blue data point is very high since it is among the blue data points.
So it is to be noted that the most complex model need not be the best model for prediction. There are hundreds of algorithms in regression, classification, clustering, and the expertise of ML engineer comes with choosing the right model with the right parameters. This video is to give you an idea of what you can expect with machine learning, and in future videos we will discuss about specific algorithms.
Thank you for watching this exciting student demonstration. I am Preeta, Secretary of Tambu Higher Secondary School. At Tambu, we are proud to be among the few schools to integrate machine learning into our academic curriculum. Our students are gaining hands-on experience in cutting-edge topics like regression, classification, and clustering, building a strong foundation in technology and data science. This video is just a glimpse of what our students are capable of. We believe that by nurturing these skills early, we are opening doors to future-ready careers and global opportunities for our students. If you'd like to know more about our innovative programs or how your child can benefit, please reach out to our admissions office. We'd love to hear from you. Thank you once again for watching and for supporting the next gen of tech leaders right here at Tambu. Thank you.